Episode 20, Design, Deck. Designing a deck is much like the design of the house beams and joists, but the load and span requirements are different. Minnesota provides a good 3-page code summary and overview, and it directs the user to the 2020 Minnesota Residential Code for specifics. URLs are below in the contents. There are also several good guides from Minnesota cities that I found to be helpful. City of Blaine and the City of Bloomington. Links are below. Here are some of the items out of the code. The sizing for deck footers is specified in a method similar to house footings. The diameter of each footer is related to the square feet of deck supported. Based on the code and max spacing of beams and joists, my design ended up having 18 posts, lettered here from A through U. You will notice that I didn't use the letters I, L, or O. Those letters are too easily misidentified as numbers or as the wrong letter. Focusing in on the deck area supported by post P, you notice that it will support half of the distances left and right of the post, half of the distances above and below the post. This results in a lateral support distance of 8 feet and a vertical support distance of 5.5 feet. I did this calculation for every post so as to see what size footer I would need to support the deck area of each post. The resultant table for each post is shown here. You can see that posts P and Q support the most area, 44 square feet each, and therefore each have a footer diameter requirement of 21 inches. The 4 smallest areas supported are from posts A, H, B, and G, with a resulting footer diameter of only 11 inches. I have also included the area of the footers in square inches in case a circular footer is not available and I need to purchase a rectangular-based footer. The footers that I plan to use are known as Bigfoot footers. There is a link for them below. They have both a 20-inch diameter and a 24-inch diameter footer. Home Depot carries the 20-inch Bigfoot. The footers are to be bell-shaped, 12 inches thickness minimum. The below-surface depth of the footers is predicated on your location in Minnesota. Where I am, Zone 1, I'm required to have 60-inch deep footers. The footer uprights will be through tubes such as this. For poster beams not to exceed 4 inches side to side, the tubes will have an 8-inch diameter minimum. The code also outlines permissible deck loads and spans. I chose to go with beams that are made of 2 2x10s, 9 1/4 inches high each. For joists, I'm using single 2x10s, 9 1/4 inches high, with 16-inch spacing. You can see my calculations here for joists and footer spacing. All these calculations resulted in the diagram we saw earlier. You can see here the 16-inch on-center joists, the placement of the posts, and the placement of the beams on the posts. The code also specifies the placement of the leg bolts for the ledger board. I used the recommendations from Mike Guertin, Installing a Deck Ledger. The link is in the comments. I looked at a number of online deck design software options. The 2 winners were Lowe's and TimberTech. Links below. You can see some of the design drawings here. The output from the Lowe's software is a deck report that includes multiple drawings with measurements, load analysis, pick list of items to purchase, recommended tools, and recommended fasteners. We also need to choose the fasteners to place the supports on the footings. I decided to use the Simpson ABA 44Z, link below. Episode 21, Permits and Inspection Requirements. The number of permits and inspections that will be required for your building project varies greatly based on your state and county. Some jurisdictions inspect you every time you turn around, having inspections including items like shower pan drainage, plumbing rough-in, and others, accumulating in a certificate of occupancy. Other jurisdictions aren't quite as stringent, which can be a double-edged sword. It makes your building project easier to accomplish, but it also takes away protections, both for you as a builder and for any future home buyer. Polk County in Minnesota is one of the less stringent counties for permits and inspections. There were only a total of 7 that I had to accomplish, 3 permits and 4 inspections. The 3 permits were electrical permit, land use zoning permit, and building permit. The 4 inspections were property lines and lake setback inspection, septic compliance inspection for the Minnesota Pollution Control Agency, rough-in electrical inspection, and final electrical inspection. The electrical permit in Minnesota allows for a home builder who is not a licensed electrician to wire their own home as they build it. The home builder certifies that they will do all the work and not subcontract it out. The land use zoning permit allows for removal and introduction of soil. The removal is the taking of the soil away when you dig your foundation, and the introduction is when you add topsoil as you landscape. The building permit allows you to begin construction. Part of the application for the building permit is the submittal of a septic plan. Polk County combines the land use and building permits into one sign that is posted during construction. We began our project once I had my 3 permits in hand, with inspections where indicated. The first inspection was the property line and lake high water mark setback inspection. I had to begin by having a lot survey to establish exactly where the property lines, historic high water line, and construction setback lines lay. The permissible setback is indicated by the dotted line on the survey. With the survey in hand, I then staked out the footprint of the house and deck. An inspector arrived with a tape measure to see that the proposed structure lay in the allowed construction area. The next inspection was my septic compliance inspection. I had an existing septic system that the prior lot owner had installed. An inspector arrived one day, in my absence, and tested the soil for rust traces and percolation. He then notified me that the existing system had failed and I would need to build an above-ground mound system. I challenged his finding and had him come back out accompanied by a county representative to retest the soil. Prior to them returning, I acquired the septic inspector's guidebooks and training manuals. It's nice to have strength through knowledge. They had tested a low area of the property, indicated by the red dot. My septic system was in a higher, drier area, and upon reinspection my system passed, and I did not have to spend the money or time to install the unsightly mound system. Due to the size of my timber frame, though, I needed to add an additional 1,250-gallon septic tank in series to my existing system. Upon passing, I received my much-desired Certificate of Compliance. The last inspections are the 2 electrical inspections, the rough-in electrical and the final electrical. The rough-in is accomplished when the studs are all still exposed and the wire runs can be seen throughout the house. This way, needed corrections can be made to wire size, number and placement of outlets or switches, if necessary. The final electrical inspection is done when the interior walls are finished and you are about ready to move in. This tests for polarity and proper installation of your receptacles. This inspection also serves as a de facto certificate of occupancy, in that the electrical permit states, the installer must notify the inspector for final inspection when the wiring is complete and before the wiring is utilized and the space is occupied. Episode 22, Acquire Tools. Since I was building a house for Carrie, she said I could get any tools I needed. There were 6 main categories of tools: hammers, levels, etc., electric hand tools, pneumatic hand tools, fixed saws and planers, a laser level, and a telehandler. Here are some of the basic non-power tools I needed. Hammers, standard 16-ounce claw hammer. Note, you can see that the rubber has worn off the handle of one of the hammers. I think these were Stanley hammers. Perhaps a different brand would be nice so the grip on the hammer would last. A 2-pound sledgehammer with a short handle, a 6-pound sledgehammer with a long handle. Screwdrivers, crescent wrenches, sockets, tape measures, a 25-footer and a 300-footer, pry bars, L-squares, 6-inch aluminum speed square measuring rafting roofing triangle, a 4-foot construction level, torpedo level, wire cutters, pliers, tin snips, extension cords, fish tape, adjustable drywall T-square, and a carpenter's apron. For electrical hand tools, I debated between the Milwaukee cordless E18 and the DeWalt 20-volt tools. I researched the comparisons a bunch and chatted with some local workers. It seemed like a toss-up, and in the end I decided to go with the complete set of Milwaukee cordless E18. I found that Home Depot has a good selection of combo kits, and I purchased these tools from them. For pneumatic hand tools, I started by purchasing a Bostitch 6-gallon compressor kit with tools from Lowe's. I then purchased more tools, ending up with a framing nailer, 3 different finishing nailers, 2 staplers, and a palm nailer. These were various makes, including Hitachi, Bostitch, DeWalt, and Metabo. If you've never had or used a palm nailer, they are the cat's meow. You can get into small areas and put in nails very quickly and simply. They are especially handy when nailing joist hangers to your joists. For fixed saws and planers, I had the following: a DeWalt compound miter saw, a Metabo compound miter saw, a Sears Craftsman planer molder, and a Sears 10-inch radial arm saw. A project of this magnitude needs a commercial-grade laser level. I talked to local builders and settled on the Spectra Precision LL100N. It worked great as I used it to level post beams and other major construction items. The last major item I needed for construction was a telehandler. A telehandler, also known as a telescopic handler, combines the capabilities of a forklift and a crane, featuring a boom that extends upward and outward for lifting and placing materials in hard-to-reach areas. A telehandler has 3 different methods of steering. First, you have crab steer, where all the wheels go the same direction. This prevents the telehandler from pivoting, allowing you to maneuver diagonally. Next, you have all-wheel steer, which allows for very tight turning radius. The front and rear wheels turn opposite directions. Fronts go right, rears go left, and so forth. Last, there is front-wheel steer. Front-wheel steer is your standard steering mode, just like a car, with the front wheels controlling the direction of the machine. In this mode, the rear wheels remain straight.
Okay, tip them forward. Okay, now lower them the rest of the way.